Hello everyone, in this video we're going to explore topic 5.8 and 5.9, relationship between the function, the first derivative and the second derivative. Alright, first we're going to grab the derivative function f prime given the function f, right? Now this one is the quadratic function, right? So for example, if you have y equals 2s squared plus 3s plus 1, alright, and then you're gonna take the derivative of this one. It turns out to be 4s plus 3, right? So this guy turns out to be linear, right? So you see that this is the quadratic function, then the first derivative should be the linear function, right? It's match this one, right? So how do we graph this one? Alright, so you look at this one right here. The relative extrema of the parabola becomes the zero of the first derivative, right? Now next one, you're gonna draw the tangent line on the left hand side of the relative extrema right here, and you see that the slope of the tangent line is negative, right? So when you graph it on the graph of the function f prime of s, it is below the x-axis, right? On the right hand side, you draw the tangent line and you see that the slope is positive, so it should be above the x-axis, right? Now here's the Christmas tree trick. If the tangent line is going this way, the slope is positive. Tangent line is going this way, slope is negative. Tangent line is going this way, slope is 0. Tangent line is going this way, slope is undefined, right? Now the second one, this one is the cubic function, right? So for example, I have y equals 3s power 3 plus 2s squared plus s plus 1, right? Now if I take the derivative of this one, it's going to be what? 9s squared plus 4s plus 1, right? So it becomes quadratic, right? So this one, you see that when you take the derivative, it becomes a quadratic function, right? Now how do we graph this one? We look at this one right here. The relative extrema of the original function becomes a zero of the first derivative function, right? So it could be 0 right here, right? Next one, this one is the inflection point. All inflection points become the relative extrema of the first derivative function. Now we're gonna check this one first, right? So from here to here, we're gonna draw the tangent line. We see that the slope of the tangent line is positive, so it should be above the axis, right? From negative infinity to this guy, right? Now draw another tangent line. You see that from here to here, it should be negative, right? The slope is negative. It should be below the axis, right? Now from here to here, when you draw a tangent line, it should be negative, right? So it should be below the axis. Then the point of inflection right here becomes a local minimum of f prime of s, right? Now next one, we draw the tangent line of this one. We see that the slope is positive, so it should be above the axis, right? Now let's move on to the last one. This is the quadratic function, right? We're gonna locate the relative extrema of this function, right? It's gonna be right here, it's gonna be right here, and it's gonna be right here. So we have 2 minima and 1 maximum, right? So all relative extrema becomes the 0 of the function of f prime of s, right? So we just project out 0 right here, 0 right here, and 0 right here, right? Now this guy and this guy are inflection points, right? So it's gonna be relative extrema of the function f prime of s, right? So I draw the tangent line and see that the tangent line is going down, the slope is negative, so this guy should be below the axis, right? Next one, from here to here, draw the tangent line. It's gonna be positive, right? So it's gonna be above the axis, above, right? And then this one, keep doing that, draw a tangent line. The slope is going to be positive, right? So it should be above the axis, right? So it will be like this, right? And then the inflection point right here becomes the maximum, right? Similarly, I'm going to draw the tangent line right here. I see that the slope is negative, right? So it should be below the axis, right? Similarly, this guy, the slope is negative, it should be below the axis. Then the point of inflection right here becomes minimum value, right? And then the last one, I'm going to draw the tangent line of this guy. The slope should be positive, right? Then it should be above the axis for the function f prime of s, right? Alright, what do you notice about each pair? Now, if the slope of the tangent line of f of s is negative, right? Look, the slope of the tangent line is negative. Then the graph of f prime of s will be below the axis, right? Below right here. If the slope of the tangent line of the function f of s is positive, right? This guy is positive. Then the graph of f prime of s will be above the axis. Look, it's above the axis, right? Now, all relative extrema of f of s will become x-intercept of f prime of s, right? Look, you have the minimum. This guy becomes the 0 of f of s, right? Maximum and minimum becomes the 0 of f prime of s, right? Minimum, maximum, minimum becomes the 0 right here, right? Now next one, all points of inflection of f of s will become relative extrema of f prime of s, right? So you see that the point of inflection right here becomes the minimum, right? The point of inflection right here becomes the maximum. The point of inflection right here becomes the minimum, right? Now, if f of s is an odd function, then f prime of s is an even function. The converse is not necessarily true. If f of s is an even function, then f prime of s is an odd function. Similarly, the converse is not always true. Now, let's move on to the first example. Sketch the function of the f prime of f given the function f of s. Right? Now, this one is the absolute value function. Right? First, we need to find the slope of the tangent line. Right? This one is the linear from here to here. The slope of the tangent line is negative 1, right? So, it's going to be negative 1 right here. Right? From negative infinity to 2, right? Now remember that this one is the sharp turn, and you learned before at the sharp turn the function is not differentiable, right? So right here you should have the hole, right? Next one, from 2 to positive infinity, the slope is 2, right? So it's gonna be right here, the hole right here, and it's gonna be like this. This one is the graph of the function f prime of s, right? Now let's move on to example number 2. Given the parabola, we need to sketch f prime of s, right? This one is f of s. Alright, we need to locate the relative extrema, right? The relative extrema becomes the 0 of the function f prime of s, right? So it's gonna be right, s equal to y equals 4, right? So the 0 is right here. Alright, next one, you need to draw the tangent line on the left of 2, right? So it could be like this. And you see that the slope of the tangent line is positive, right? Which means it's gonna be above the axis, right? So it could be something like this. Now second one, we need to draw the tangent line right here. And you see that the slope is negative, right? Which means the second half should be below the axis, so it could be something like this. And this one is the graph of the function f prime of s, right? Now let's move on to example number 3. First, you need to locate the minimum and maximum, right? This one is the minimum, this one is the maximum. Minimum and maximum become 0 of the function f prime of s, right? So it can be 0 and 2, right? So 0 here and 2 here. Now the point of inflection is right here at 1, right? This guy becomes relative extrema of this one, right? So it could be right here. Now from negative infinity to 0, we need to draw the tangent line of the function fs, and you see that the slope of the tangent line is negative, right? Which means the graph of f prime of s should be below the x-axis, right? So it could be something like this. Next, we need to draw the tangent line from here, and the slope is positive, right? So this guy should be above the axis, right? So it could be like this. Next one, we draw the net tangent line, and this one is positive, right? It's still above the axis. And the last one, draw the tangent line, it should be negative, right? So it should be below the axis, something like that. Now let's move on to example number 4. Alright, so we just draw the tangent line of this guy, right? And we see that the slope of the tangent line is getting smaller and smaller, right? But it's positive, right? So the graph of the function f prime of s should be above the axis, right? So it's gonna be something like this. Alright, now example number 5, sketch the function f prime of s given the 4-degree function. Alright, so first we need to locate the minimum, maximum, and the point of inflection, right? So we have the minimum right here, and we have the point of inflection right here. The minimum becomes the 0, right? So I have the 0 should be somewhere right here, right? And the point of inflection becomes the maximum or minimum, right at 0, so it could be right here, right? Now I'm going to draw the tangent line. The slope of the tangent line is negative, right? From negative infinity to 0, right? Which means it's below the axis, right? So it could be like this. Now from 0 to 2, I'm going to draw the tangent line, and I see that the slope of the tangent line is negative, right? So it should be below the axis, so it could be something like this, right? And then from 2 all the way to close to 4 right here, right? And I'm going to draw another tangent line. I see that the slope of the tangent line is negative, right? So it's still below the axis, right? So it could be something like this. And then from close to 4 all the way to positive infinity, the slope of the tangent line is positive, right? So it should be above the axis, so it should be something like this. Now let's move on to example number 6. From negative infinity to negative 2, you see that the slope is 0, right? So it should be on the x-axis, right? And then you see that right at the sharp turn right here, the function is not differentiable, right? So I'm going to draw the horizontal line on the x-axis from negative infinity to negative 2, right? And right here it should be the open circle because it's going to be undefined, right? Now from negative 2 to negative 1, you will see that the slope is positive, right? The slope is positive and it's going to be equal to 2, right? So the slope equals 2 from negative 2 to negative 1. So it's going to be right here. The slope equals 2, so it's going to be like this. Again, right at this point, the function is not differentiable because it had a sharp turn, right? Now, from negative 1 to 1, right? It's going to be right here. The slope is 0, right? So it's going to be on the x-axis, right? So negative 1 right here to 1 right here. The slope is 0, so it should be like this. And then this one is the minimum, this one is the maximum, right? So it becomes the 0 of the derivative function, right? So it could be 2 as right here. I have 1 0, and right here roughly 4, right? So it could be something like this, right? 2 0, and then the point of inflection is right here at 3, right? So it becomes maximum, right? So I leave it over there. Now I'm gonna draw the tangent line right here. I see that the slope of the tangent line is negative, right? From 1 to 2. So from 1 to 2, the slope is negative, the function below the axis, right? And remember, right at this point, the function is not differentiable, right? Because this has a sharp turn, right? So it's gonna be, now I'm gonna draw another tangent line right here, and I see that the slope of the tangent line is positive, right? From 2 to 3, right? It should be above the axis, right? Now the point of inflection is at s equals 3, right? So this point becomes the maximum of the function f prime of s, so it could be something like this. Now I'm gonna draw another tangent line. I see that this is positive, right? So it's still above the axis, so it could be like this. And I draw another tangent line, it's gonna be negative, right? So this guy should be below the axis. Now let's move on to example number 7. Alright, given the function sine s, right? So now we need to locate the minimum and maximum, right? So minimum right here and maximum right here, they become the 0, right? So it could be right here and right here. Alright, and the point of inflection right here become the maximum, right? So it could be somewhere right here. Now I need to draw the tangent line of this guy, and I know that the slope of the tangent line is negative, right? So it should be below the axis, right? So it could be something like this. From here to here, the slope is positive, right? So it's gonna be above the axis, right? So it could be like this. From negative 1.5 to 0, right? Negative 1.5 to 0. And then from 0 to 1.5 right here, the slope is positive, so it could be above the axis, so it could be like this. Now from 1.5 all the way to infinity, the slope is negative, right? So it could be below the axis, so it could be something like this, right? Now we can use the graphing calculator to check out work, right? So we're gonna bring up the calculator, hit add graph right here. Now function f1, we need to put sine s, right? Hit trick sine s and hit enter. It's gonna be like this, right? Now I'm gonna restrict the domain so that it looks like this one, right? So I'm gonna hit menu, window, zoom, and then window setting right here. So s min, I'm gonna put negative 4. S max, I'm gonna put 4. Y min should be negative 2, and Y max should be 2, right? Enter. It's gonna be something like this. All right. Now I need to graph the function f prime of this guy, right? So I need to hit tab, and then I need to hit this button right here. That's next to number 9, right? I'm gonna hit this one, derivative right here, right? Now I need to take derivative of the function sine s with respect to s, right? So I need to hit f1 of s, right? Then I hit enter. And you observe that the minimum of the original function becomes the 0 of the derivative function, right? The maximum right here becomes the 0 right here. You see that? The point of inflection right here becomes the maximum. It matches this guy. You see that? Now I just find the minimum, maximum, and the point of inflection, and I'm gonna match this guy to see how it looks like, right? So I hit menu, analyze graph, the minimum, right? Minimum of this guy, right? So I need to move cursor to the left, to the right. It's gonna be right here, right? Now I need to find the 0 of this guy, right? So I need to hit menu, analyze graph, 0, right? Move my cursor to the left of 0, move to the right of 0, and you see that this guy and this guy are the same. You see that? Negative 1.57, negative 1.57 right here. they're both the same, right? Similarly, you will get this guy and this guy the same. This guy and this guy the same. This guy and this guy the same, right? Now, let's move on to the last one. Sketch the graph of the rational function. Observe that this one is the rational function and it's going to be undefined at s equals -4 because -4 is the vertical asymptote, right? So when you turn this one into the derivative function, it's not differentiable at s equals -4, right? Now you're going to draw the tangent line and you see that the tangent line is getting steeper, right? Which means it's going to be positive, right? So it's going to be above the axis, so it could be something like this. Alright, similarly, you're going to draw the tangent line of this guy and you see that the tangent line getting less steep, right? And the slope is still positive, right? So it could be like this. Let's use the calculator to check this one. This guy actually f of s equals. So we're gonna bring up the calculator. We're gonna sketch the function f of s equals s plus 2 over s plus 4. And then you hit enter. It's gonna be like this, right? So now you hit tab. f2 of s is derivative of f1 of s, right? So you hit this guy right here with respect to s. Right here, you just type f1s, right? And you hit enter. It's gonna be like this. See that? It matches this guy right here, right? And it's your time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.